Welcome to Pomodoro Joe for Monday, April 3rd, 2023. Today we're looking at LeetCode problem 881, Boats to Save People. It's a medium problem. So the problem statement says, you are given an array people, where people index I is the weight of the ith person, and an infinite number of boats, where each boat can carry a maximum weight of limit. Each boat carries at most 2 people at the same time, provided the sum of the weights of those people is at most limit. Return the minimum number of boats to carry every given person. Okay, so in this problem, there's a ship that's sinking, and we need to save all the people on the ship. But all we have are small 2-person life rafts, and each life raft can only carry at most limit weight. So our task is to get all of the people off the ship by using these small 2-person life rafts. And our specific task is to say how many life rafts we need to get all the people off the boat. All right, this one seems pretty straightforward, so we'll put 25 minutes on the timer and get started. So the way we approach this one is we need to get all of the people off the boat. We'd like to minimize the number of boats we use. In order to do that, we have to maximize the use of each boat. Since each boat can only carry 2 people, that means we need to pair people up in such a way that we can get as many people together onto boats as possible. Now, each boat has this weight limit, so we need to make sure that these pairs of people that we match up have to be below this limit, or less than or equal to. So how do we make sure that we match people up in such a way to maximize our usage of the boats, or minimize the number of boats we use? Well, for this one, we're going to match the heaviest people with the lightest people. So we'll find the heaviest person, match them with the lightest person. They become a pair, we'll put them on a boat. Then we find the next heaviest person, and we'll match them with the next lightest person. And we keep going until everybody is on a boat. Now, what happens if we match a heavy person with the lightest person there, and they're still over this weight limit? Well, then we'll have to send the heaviest person on a boat by themselves. At this point, that heavy person can't match with anybody because we tried matching them with the lightest person and it didn't work. So that heaviest person's going to have to go by themselves. So we'll send them on a boat by themselves, and we'll keep going matching the next heaviest person with the lightest person. So what we really want is a way to find the heaviest person and the lightest person very quickly. So we'll just sort all of the people. If we sort the people by weight, we can just choose the lightest person, or the person at the left end of our weight list, and we'll choose the heaviest person, the person on the right end of our weight list. So let's do this. We'll sort our people. So now that the people are sorted by weight, all of the lightest people will be on the left end, and the heaviest people will be on the right end. So we'll keep an index into each side. So we'll have the low index, which will have the lightest person, and we'll have the high index, which will contain the heaviest person's index. So that'll be the length of people minus 1, because the index will be 0 indexed. Okay, so now we have our low and our high. Now we just need to go through and match all these people up. So we will keep our result. So this is how many boats we need, and at the end we will return this result. Now we need to go through all the people. So while our low index is less than or equal to our high index, which means we still have people that we're sorting through, we will grab the low person, the high person, so that's the lightest weight person, the heaviest person, see if they match. So if sorted people at the low end plus sorted people at the high end, so that's taking the lightest person and adding their weight to the heaviest person's weight. Now if that is less than or equal to our limit, then we're all set. We'll just put them both on a boat and move on. So how do we, quote, put them on a boat? Well, we'll just increase our low index by 1, and we'll decrease our high index by 1, and we will increase our result by 1. So we will move on to the next lightest person and move on to the next heaviest person, and we will record that we used 1 boat for this pairing. Now, if this pair exceeds our limit, we can't put them both on a boat, but we need to put somebody on a boat. So we'll put the heaviest person on a boat. So we'll subtract 1 from high, and we'll record that we used a boat for this heavy person. And the lightest person just will have to wait for the next boat or the next pairing. Now, it looks like we're doing some redundant work in here. We have low, high, result. In either case, we're moving down 1 in the high index, and we're recording our result. It's only when we have a matching pair that we increment our low. So it looks like there's some redundant work in here. So let's just consolidate all that. There we go. So now this is our algorithm. If we find a matching pair, we'll put them both on the boat. If we don't find a matching pair, we just put the heaviest person on a boat. All right, let's see if this works. Okay, that works. Let's submit this. And we pass. And we do pretty well. We beat 86% for runtime and 18% for memory. So yeah, that's not too bad. We'll take one last look here. So it's pretty straightforward. We have to sort the people first so that we have all of our people sorted by weight from low to high. Then we keep track of where the lowest weight person is and the highest weight person. Then we'll just go through, and while we still have people to put on the boat, we will check to see if the sum of the lowest weight person and the highest weight person exceeds the limit. If it does not, then we'll just put them both on a boat and move on. If it does, then we'll have to just put the heaviest person on a boat and move on. So one thing we can do to speed this up and use less memory is right here. So this sorted people is a copy of the people list. And there's a good reason for doing it this way. In a real production environment, you don't want to be modifying your inputs unless it's explicitly said that you will be modifying the input. So Python does pass by reference. Now, if you don't understand what that means, that's okay. The point is that this people list inside of this function, if you modify it, it's modifying the actual people list that's being used by our solution class. If other functions will be using the same people list, if we modify it in this function, those later on functions will get the modified version of the people list. Now, sometimes it doesn't matter, like in our case, it's probably not going to matter, but in other cases, that might matter. And so you don't want to be modifying these inputs unless explicitly said that you can, or unless you explicitly declare that you're doing it and that other people who use your function know that you're doing it. In this case, however, it's just slowing us down. So instead of doing this sorted people equals sorted people, we can actually just use people.sort to sort the people list in place. This will sort the people list in place, meaning it will modify this input people list. Then down here, we can just use people instead of sorted people. So this should save us a little bit of runtime and a little bit of memory. All right, let's submit this. It doesn't actually save us any runtime, but it does save us a lot of memory. We're at 96% for memory, 73% for runtime. That's a little surprising. I would have expected the runtime to be faster as well. All right, I don't know if there's much I can do then to get this to 100%. We will go back to our sorted people here. There's not much I can do to really make this any better. We can try to put this back the way we had it here. Let's see if this makes any difference. A little bit. We're at 82%. Our first attempt was 86%, so it doesn't really make that much difference. It slows us down a little bit. I wonder if keeping this space in here will make a difference. And it does. For some reason, having that space there, I guess maybe in parsing, you have to do one extra line. I don't really know the difference. So the difference between our first attempt, which was an 86%, and our last attempt, which was a 95% for runtime and 60% for memory, the only difference was this space right here. Yeah, you got me. I don't know why that difference, that empty space made that much of a difference. The only thing I can think of is in parsing, you'd have to parse that one extra line. All right, well, we got a 95% for runtime, a 60% for memory. That's pretty darn good, so I'm gonna stick with that. And that's it for me today. Hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.